Now, members, let us see how we handle this question. It says, show graphically that there is a root of this equaling to 0. Hence, use the Newton's Raphson formula to estimate the root of the equation with 3 decimal places. Remember, this is 3 decimal places means that your tolerance is going to be calculated like this: the tolerance or the maximum possible error. This n stands for number of decimal places, so which we compute to get this, implying that now this one, when you get the error between consecutive roots, it should be less than 0.005 in simple terms. So now, what we do here, I'm going to use a two-plot graph. A two-graph plot. Okay. Now here, what I do, I first set this function b f of x. Then here we check the roots. Oh, we check for the change of sign. And now here I'm just going to test. When x is 1, you test values that you said I'm going to give you a negative, and those which are going to give you a positive values of x. So I saw when I substitute x as 1, it's going to give me negative 2.3. When I put in x as 3, it's going to give me a positive. So these two means that my root will lie between 1 and 3, because f of this and f of this is a negative less than 1. So our root is going to be now between 1 and 3, the values of x. Now after that, we say we separate and we form two functions from the original function. So when I put this side, this one is going to be y1, and then this one is going to be y2. That's why I call it a two-graph plot. You are getting one equation, and then you are dividing to get two functions which you are going to plot. So after doing this, this is a good line. When x is 3, y is 3. When x is 2, y is 2. As simple as that. So to plot line with only 2 points. Then when you come to this, now because this is a sine function, a trig function, you immediately put your calculator in radians. So your calculator in radians, please. So when you put these values, these are the values of course, these are in radians. Because they are small angles, your calculator should be in radians. Should be radians mode. So after when I put this line, this is how I probably see that. This line in the points where 3, x is 3, y is 3, as you see, 2. Of course, it's that it's passing through 1. So the x is equal to corresponding value of y. So when I put now this one for a sign, this is what I got. Now you just need to join those points using a free hand. Simple as that. Passing to the point x there. Now there, you need where they are meeting. Where they are meeting, now you come and you approximate that value downwards there. So this is our initial root. Initial root x naught. Is that it's going to be approximately 2.45. We are approximating because it's an initial root that we are approximating for is. Now, you know that in our formula, we need f of xn and then this derivative. So what we do there? Now, note when you are plotting, my points are to 1 decimal place, which I can easily plot. So always be careful with these points, because you should make sure that you can easily plot them. So this was our y equaling 4 sine x. Now, I'm using the shaded graph because I don't have enough space. But for you, your graph should be at least reasonable enough, so that you can get that root for it. So that root is that after getting, we said you get the root where these two intersect. So it's not the intersecting there. That's why I'm getting my root like that. So after that, is that out, we said it's between 1 and I think we said between 1 and 3, but the closest one is between 2 and this anyway. As long as the concept is there. Now, our f of x, remember, was this. You know, in that formula, now this is what we call the Raphson formula. So we need now to substitute fxn in f of x and also its derivative. So our f of x was this. When I differentiate x, I get 1. When I differentiate sine, I get the cos. This is the constant, but it's a coefficient, so leave it there. When I differentiate sine, you get cos. So now in prime, I need f of xn, which is going to be, now this one is going, where there is x, we put xn. Sine xn. Then in this also, where there is x, I put xn. This will be 1 minus 4 cos xn. So after doing that, then we come and substitute into this formula. We already substitute this formula and we simplify so that we don't waste time when calculating. So our xn plus 1 will be equaling to xn. Now minus, because it's negative, you open brackets or else this will be xn over the derivative, which is 1 for cos xn. Let us multiply. This is over 1, so it goes multiply up and down. This times this you get xn minus this times this you get 4xn cos xn, then negative and this you get negative xn, negative and this you get positive 4 sin xn, the whole over this times this 1 minus 4 cos xn. So simplifying that, xn plus 1 will be, now is that this one is cancelled with this. So if you are starting with this positive, we have 4 sin xn minus 4 xn cos xn. As simple as that. So where our n is going to run from 0, 1, 2, and so on. Now, because this is our initial approximation, so you see, when our n is 0, we have, when we put here 0, we have x1 equaling 2. 4 sine, now xn is going to be our x0. So, x0 minus 4 x0 cos x0, all over 1 minus 4 cos x0, which will be, now we are substituting our x0, this is our initial value. So our x0 now is going to be 4 sine 2.45 for 5. So that here, my x1 is going to be, you put that structure, I told you how to put those values onto a calc. So you press that, to press that, you say, you open brackets, then you say 4 sine, then you press this, then you press this x, then you say minus 4, you need an x, then cos of x. Then you close that bracket, then you say you are dividing with, open brackets, 1 minus 4 cos alpha, then you press this x here. Then you close brackets. Then after doing that, you press this button, curl. Press it to ask you which value of x do you want to put in. I want to put in 2.45. It will give you 2.47. Now, because they want us to give to 3 decimal places, now we'll give our answer to 4. Because they want to 3, we always give to more, so that we around that unit of rounding off. So this will be 2.4748. Now I'm giving it for decimal places. Now, this is going to be my x1. Now it's that when I get x, now 1 minus x0, when you get, you want to see the tolerance between these two. Our x0 from here, it was this. When you subtract off this, the answer we get is 2.4748 minus 2.45. The answer we get is 0.0248, which is not less than 0.0005 this tolerance. Then we move now to when n is 1. When n is 1, we are going to be having x2 equaling 4. Now sine of x1. Now this one is going to be x1. My x1 is here, 2.4748 minus 4. Then cos of 2 the whole over 1 minus 4 cos 2.4748. Then here we get our x2 equaling 2. We open our brackets, then we put the same the way I told you to press it on the calculator. My x2 is 2.474, then 6. Now, if I come and I set my x2 minus x1, see, we shall get 2.4746 minus 2.4748. Here I'm getting 0.0002, which is less than 0.0005, which is good. So now meaning that my x2, that value becomes 2.4746. So the value I'm going to take, because the difference between it and this one is very small, but we say it should be to 3 decimal places, which is 2.475. 3 decimal places, and that becomes our answer. So that's it, members. That's how you use the vertical method, estimate the root. We are going now to see when they tell you using interpolation, what happens there. See that lesson. Now, these values are always the initial values, the initial approximations we use. That's why I'm adding it there.